Hello everyone, welcome back. As usual, your cameras, if you can turn on your cameras, could be appreciated. First, homework for this week. We're going to be talking about design patterns. We're going to start with the design patterns, then we're going to move to the architectural patterns. Just to be sure that you have an idea of what is that, I am asking you to read this paper. It's posted on Canvas, so you can get the paper. The context. This paper is a paper from '93. The authors are the same that the authors of this book. In fact, the paper is basically the beginning of the book. If you remember, the book is '94. The paper was published 1 year before. If you haven't read the book, if you are not aware of the book, if you are planning to work in some software engineer related career, developing software, highly recommended for you to read the book. For this class, the only thing that I am asking you is to read the paper. It's a summary of the book, but also is a version that is older than the book. You can notice some differences if you read the book and the paper. The book is better, obviously, but at least what I want is for you to have the context of why this book was created and the big picture of the design patterns. We start today talking about the topic, but please, if you can read the paper before our next lecture, that could be great. So homework, read the paper. Moving forward, good solutions. Good solutions, well, the fancy name for good solutions is patterns. In software, a solution to one particular problem that we consider good enough, that we consider that, hey, that thing works. That is a good one. That is something that should be used in other problems that you have that are similar. The name for that is patterns. In particular, we're going to be talking about design patterns, and we're going to talk later about architectural patterns. Patterns for the architecture of the software, a topic that we need to cover later, and patterns for the design. In particular, the patterns for the design every single design pattern is a good solution expressed or documented as a class diagram. It's a class diagram, and therefore is something that you can translate to source code. Design patterns, class diagrams, templates that you can use in your projects. And just following the class diagram, you know which source code you need to create. Here, we're going to review several. Later, when we finish, we're going to move here, and we're going to review others. So, for today, here, design patterns, class diagrams. We're going to be working with what is called the GOF patterns, the Gang of Four patterns. The Gang of Four, you will notice this book have 4 authors, and they are the Gang of Four. They propose 23 patterns, 23 good solutions, 23 ways to solve 23 particular problems that works well. Now, let me be clear. There are 2 ways in which you can create good solutions. Number 1, you can invent a good solution. Number 2, you can discover a good solution. Do we understand the difference? What is the difference between inventing something or discovering something? Ideas. discover, invent. Okay, thank you. Design patterns. Good solutions in software, you do not create them. It's not like I am the professor and I have this good idea, so this is a good solution. In software, that will not happen. These 23 patterns, they are not good ideas that these 4 people have. We are not trusting these 4 people and just believe that they come with these 23 good ideas. That is not the case. They discover these patterns, They go and review software outside, software that they do not create, software that was created by someone else. And by reviewing the different solutions, the different things that different developers did, they found similarities. Hey, this programmer here and the programmer there and the team there, all of them solve this particular problem with this particular set of classes or with this particular method or using this particular code. And in all these 3, 4, 5 cases, the solution is working. It's a good solution. It's something that I can teach others to follow. The 23 patterns, they are discoveries. They were discovered. They exist and they were created by someone else, the unknown developer. But these 4 guys document their findings in patterns. Makes sense? Now, usually my students ask the following, using the patterns, versus Professor, you're asking me to use a pattern. You're asking me to learn those 23 patterns, and when I have a problem, you're asking me to apply that solution just because that solution is a good solution. What about innovation and creativity and all that stuff? On the one hand, you have a solution that is working. Could be the best solution, maybe there are better, but this solution, the pattern, is working, and that is have been proven. And on the other hand, you have your creativity and your innovation. What are you going to do? A solution that have been proven and work, maybe there are better, but these at least work. Or creativity and innovation. There is no one answer, guys. The answer is, what do you want? Maybe not you, the company that you are working for. Or if you are the company, well, you take the decision. Do you have the time, the resources, and the money to do innovation and creativity? If yes, go ahead. Maybe you can find a better solution than the patterns. Or you just want a solution that is going to work because your company is doing this particular product, and for that particular product, you need to solve a particular problem in a way that works. Up to you. It's exactly the same decision that you take when you select a data structure. You're going to use a data structure that exists, or you're going to create a new data structure. You want to search for information. You're going to use quicksort, bubble sort, or any of the sorting algorithms that already exist, or you're going to go ahead and try to find something better. Up to you, depending on what is your goal in your company, in your team. What do you do? The things that we're going to review here is at least let you know that for some problems, there are solutions that exist, that have improved. And if you want to innovate and be creative, you need to find something that is better than the solution that I am going to share with you that exists. And you're going to have at least one point of comparison of your solution, your creativity, your innovation, whatever. Is not this one versus what my friend is doing there. Is this one versus the pattern, this one versus the standard. So you really could have an idea if your new idea is as good as the standard or better than the standard. That is the point. Knowing the patterns is knowing at least the basic for the solution, the good solutions that outside are implemented. Good. Now, who use these solutions? Almost every single software that you use follow the patterns. And I am going to show you examples. If you think about the Java API is full of these patterns. We're going to review examples. Good. So use my point regarding innovation and creativity. They are important, but there are standard solutions. And the first thing that we need to know as an engineer is the standard. And then we can compare our innovation. So talking about the standards in the timeline, we're going to start with 93, with the paper that you're going to read, the Gang of Four. 1 year later, we're going to read another paper that I'm going to share with you, David Garland from Carnegie Mellon. And 1 year later, we're talking about software architecture. The 80s was all about object-oriented. The 90s is going to be all about standards, patterns for design and for architecture. So this is what we're going to be doing this week and the next one. Patterns, design patterns. 23, yeah, these are the 23. 23 patterns for design. They are classified in 3 categories. We have patterns to create things. We have patterns to represent the structure of things. And we have patterns to represent the behavior of things. Creation of things. What things? Creation of what? Patterns to create objects, correct. But what do you do to create objects? A programmer, when we talk about creating objects, a common programmer thinks about new, and then you call the constructor. I mean, call the constructor with the new operator. Create an object, use the new operator. You need the new operator. The question in software design is, where do you put the new operator? In any place? No. You cannot put the new operator in any place. That is a very bad decision in terms of design. And we're going to talk about why. So we have these options about how to create objects, where to put the new, and how to use the new depending on particular circumstances. Okay, structure. A structure of what? Remember, we're in the object-oriented paradigm, right? Creating objects, structure. If you remember, a structure is all about elements and their connections. Here, connections between elements, the elements, classes. The structure or the structural design patterns is, how do we connect classes? We know that the only way to connect classes is with inheritance, composition, association, We have those relationships. But this is kind of the zeros and ones in programming. And you do not do programming with zeros and ones. You do programming with a high-level programming language. The high-level programming language is translated to zeros and ones. You do not connect classes used with inheritance, association, composition. No. When you have a problem, you are going to select, or you can select one of these, and this is going to be translated with those primitive connections. Again, the patterns do not cover all the possibilities, all the problems. But when you have a problem and that problem is already documented as a pattern, the priority is to use the pattern instead of working with these zeros and ones, with this inheritance, composition, association, and so on from scratch. That is a very good definition. The patterns are this high-level combination of those relationships. Exactly. Just like if you think about ifs and fors and so on in programming, they are high-level compared with using zeros and ones. These are my zeros and ones. These are going to be my high-level structures. In the same way that you do not do programming with this, you use this for software design, we're going to be using this. We need to review. And finally, behavior. Behavior of what? What is a behavior? In terms of object-oriented. Hopefully you agree with me. Yeah, functionality, exactly. When we talk about behavior, it's a fancy name, a fancy word to talk about the functionality. The functionality of what? Objects. Yeah, it's connected with the idea of methods. The idea of methods and the idea of where do we put those methods? Which method call which other? Because remember, all this idea of behavior is the methods. The idea here is in which class I put the method. And that method is going to be alone or is going to be using another one. Okay, it's going to be using another one. And that other one is going to be where? In the same class or in another class? The connection between methods and where those methods live is going to be the key idea regarding behavioral patterns. So, 3 categories: creation of objects, behavior of objects, and structure. Structure of classes. Now, in order to have objects, I need classes. And if I am dealing with the structure of the classes, the consequence is going to be also the internal structure of the objects. All these patterns, classes and objects, behavior, creation of objects, behavior of objects, but we need to define the classes, structure of classes, and that is going to be as a consequence, the structure of the objects. So things that we need to review. Okay, good solutions for these 3 activities. Good. Now, next step. I want to review with you one pattern in each category. I want to be sure that at least one pattern of each category, it is 100% clear for you. That is going to be the beginning, and then we can learn on others. But at least one of each category, so you can identify what is the goal of each of these categories, how they work. So in the next lectures, including today, I am going to be talking about the observer pattern in the behavioral group. Then we're going to talk about the singleton pattern in the creational group. And finally, we move to the decorator pattern in the structural group. So observer, singleton, and decorator. We're going to master those 3. First one, let's start here. Let's start talking about behavior. Let's talk about our first example of a design pattern, observer. observer pattern. According with this, you are telling me that each of these names is a solution for a particular problem. And as you can notice, the first thing that we do when we discover a good solution is to put a fancy name to the solution. All of these are fancy names for a solution for something. Observer. What is the problem that observer is going to solve? What is this observer pattern? Well, easy. In a software, what if I have one object here, and this object is a source of information? This object have information. That means that I have a class, and this class have a particular variable. I don't care about the type of the variable. I don't care about the type of the information, but this information that somehow is created in this class, maybe for a method or more methods, I do not know how, but this class have this particular variable, one or more, that are important for other classes. I need the information here. I am a class W, and I, class W, need to have access to the information in another class, like this example with the class X. Class W need access to the information in the class W. This is a problem, a very common problem in software. One class needs information from another class. What do we do to solve this problem? And if I give you the freedom to solve the problem, you can think about, like, we can use inheritance. We can make W inherit from X, and problem solved. W is going to have access to the variable. Well, we can use composition or aggregation. We can create an object W in the class X, and therefore they are variables in the same class. It's going to have access. Well, we can call a method. We can use association. Okay, you are going to use association, like this method is going to send the information as a parameter, or you are going to do a method that this one need to call, and this is going to return the data. Did you notice? I can use any of the options that I have. I can use inheritance. I can use association. I can use composition. I can use calling a method. I can send the data as a parameter, or I can send the data back with a return. All the options are available. The question is, which is a good solution when one class needs access to the data in another class? That is the problem. The observer is the solution for that problem. Now, several different examples. If we think about a video game, we have been talking, or we're going to talk about this Pac-Man video game. You have one class that is the Pac-Man. You have another class that is the enemy, the ghost. And hopefully it's clear that the ghost need to know the position of the Pac-Man. Pac-Man is one class. Pac-Man have X and Y coordinates. The ghost need to know those coordinates because the ghost should move and follow the Pac-Man. One example with games in which one class needs access to the information of the other one. The solution, the fancy name, observer. The ghost observe the Pac-Man. Access the information, but it's fancy to say observe. Give you an idea that you can remember. Okay, that is with games, but think about a program like this in which I could ask you to plot some values. And hopefully you agree with me that you are going to have one class that have the data, one class that have this, I don't know, 10, 5, 7, the values. Maybe you have one class that connect with a database. Maybe you have one class that read a file. Maybe you have a class that is creating these random numbers. And you're going to have another class that is your graphical user interface. The one is going to plot these numbers. Again, the graphical user interface is observing the source of the data. Two different classes, they need to be connected. A more common example. Do you remember the listeners in Java? I am sure that you're familiar with the listeners in Java. What are the listeners in Java? What is the concept of a listener in Java? A listener. Yeah, when we have these graphical things like JBottoms, for instance, and we want to do something when the user hit those elements, like, I have a JBottom and I make click, and I have another class, another method here, and I need that method to do something where the event happened here. It's the explanation that they give you for the listeners. Did you notice the similarity listening, observing? They are the same. You need information from another class. The listeners, what is the information? The information is someone hit that guy. I mean, that is my friend, the OK or the cancel button, and someone hit them. And I am observing and listening, and I am going to do something. Listeners listen when we're talking about graphical elements, the graphical user interface. Observing is the global concept. I am checking you. I am listening to you. It's the same. In general, the idea is if you have one object and that object, something important is going to happen, and you have other guys that need access to that information, the solution for your problem is implementing an observer pattern, period. You do not need to worry if you do association, composition, inheritance. Just follow the observer pattern and you have your solution. It's going to work, period. We understand the problem. The next point is, okay, I am going to follow the observer every time that I need to share information between two classes. What is the observer pattern? The observer pattern is a class diagram, this class diagram. Are you telling me that this class diagram is implemented here when I have an application plotting data? Are you telling me that this class diagram is somehow involved in this video game, and this class diagram is the representation of what is happening every single time that I build a graphical user interface with listeners? Yes, it's the same solution. Just like thinking about windows and doors. In your house, you have windows and doors. And if you go to any building in the university, you have windows and doors, because windows and doors are a pattern. You need to enter to some room, it's going to be a door. And you need somehow a connection with the outside, it's going to be a window. Sharing information between two classes for games, for plotting things, for graphical interfaces. An observer pattern, that's it. Okay, now, if you were experts with classes, UML class diagrams, I give you the diagram, done, move to the next. I want to be sure that we understand the class diagram, so I am going to review with you the class diagram and the source code for that class diagram. I am going to do that with some patterns, then you can learn by yourself the others. So I give you a couple of them, full detail, examples, then your responsibility, do the same with others. So what do we have here? How many classes, 100% classes do I have in the picture? I know, tricky question. What if I told you I have two 100% classes and other two that are a different kind of classes? Maybe it's hard to read, but take a look to this name and take a look to this name. Did you notice the italic at the top? I have two classes, the two below, classes, 100% classes, classes with attributes and methods. And the two that I have at the top are abstract classes, or they can be interfaces. Remember? Interfaces after classes. In particular, the original proposal is for those to be abstract classes. That is the reason of the italics, remember? You have a class, the name in italic represent abstract classes. Abstract classes, some of the methods there could be incomplete methods. Some of the methods you need to implement it in a child. Exactly. Guys, one of the things that you're going to notice in most of the patterns is the use of abstract classes and interfaces. Abstract classes and interfaces are one of the most important things that you need to use to master in object-oriented programming. Abstract classes and interfaces are going to allow us to use polymorphic behavior. And that is one of the most powerful tools that we have. And we're going to apply that almost in 50% of the patterns. Basically, every single time that we have a combination of classes and somehow we need to connect those classes, we're going to be using abstract classes or interfaces at the top. So starting here, I am going to have this abstract class or interface subject. And I am going to have this abstract class or interface observer. Number one, if you want something new, like, you know what? I want a class Pac-Man. And you know what? I want a class Ghost. These concrete things here represent the space in the template in which you can do whatever you want. The pattern is you need an observer. You want one class to be the one observing, and there are going to be another one that is going to be the one being observed. The one that is being observed, the observable one, in the original pattern is called a subject. The subject and the observer. Two elements, two roles. I am developing the Pac-Man video game. And I want the ghost observing the Pac-Man because the ghosts are going to move according with the Pac-Man. The solution for that is, well, according with the pattern, Pac-Man can have inheritance from observer and the ghost are going to have inheritance from subject. So my ghost, the class, is going to have all the particularities about what the ghosts do or what information the ghosts have, but it's going to inherit from subject. It's going to sign a contract of I am a subject. Pac-Man is going to inherit from observer. It's going to sign a contract. I am observing something. Just for the beginning, if you read this class diagram, it is clear for you that Pac-Man and Ghost are somehow sharing information. One is observer, one is subject. Okay, what else? Second, this pattern is defining, beside the inheritance, two connections. Do you remember what is the meaning of this line with the arrow in one of the ends? What is that? What are those lines? What is the meaning of those lines? Association. And in source code association, what is the meaning? Calling methods. Attribute is the diamond, remember? Having attributes is the diamond, is composition or aggregation. This guy is calling a method. I am telling you that the good solution for two classes that need to share information is they are going to have this parent, subject, and observer. And I am telling you, the observer is going to call a method in the subject. This was the Pac-Man, right? And This one, oh, no. My observer is the ghost. This is the Pacman. Are you telling me that the ghost, the class ghost, one of the methods in the class ghost is going to be calling a method in the class Pacman? Yeah, that is the solution according with the pattern. The class ghost should call a method in the class Pacman. Moreover, the class subject is going to be calling a method in the class observer. So inheritance and two methods call. Every single time that you read in a class diagram something like box, 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 inheritance, inheritance, calling a method, when you look at that picture, there is an observer in your class diagram. It's like reading in a blueprint a door or a window. It's like, oh, this is the symbol for the door. This is the symbol for the window. There are a door and a window here in this room. When you read something like this in a class diagram, you have an observer. You have this class sharing information with another class. You know the advantage of this? It's easy to read. If the only thing that you read is the class diagram, it's very easy to notice, okay, here is happening the sharing of some important information. But the second and most important thing is the programming. What do we do with the programming of this? How many times do I need to do the programming of this? Let's review. Programming. Number one, the first class that we need, the abstract classes, right? Abstract class number one, observer. That is the observer class. That's it. Yeah. Let me show you the answering a question in the chat. Here, the ghost is calling a method in the Pacman. Yeah, it's calling a method. Why is calling the method? Because need the information. Yeah, it's getting the information here. This is the most important connection. Yeah, that is the most important connection. Why do I need the others? Let me show you. One, abstract class. Hopefully you agree with me, this could be an interface. It's just one method, update. Tell me, what is going to happen? This is observer. What is going to happen when I apply inheritance? And applying inheritance, I do the ghost. An observer. What do I need to add in the source code of ghost when I do this? You're going to agree with me that my class ghost is going to implement observer. This is an abstract class, but we only have one method. In Java, this can be an interface. And therefore, I can do implements instead of extend. The only thing is, if I do this class is not going to compile unless I put here a method update. This look familiar, guys? We talked before about listeners. I am asking, this looks familiar with listeners? Did you do this with listeners? Implementing something and having to put some kind of method similar to this one update? If you have used action listeners, do you remember? Implement action listener and then put a method, action performed. Listeners, observers. Your listener, your observer. Observer, listener. And in particular, you have mouth listener, key listener, and all these categories of listeners. They are observers. They are an interface. And the only thing that they have is a particular method that is empty that you commit to override in your classes, like I am doing here. So step number one, the ghost is going to have this update method. That's it. Second, this is my concrete observer. This is kind of my class, the ghost one. The only important thing here, the update, the override of that. Everything else is just whatever your class needs. It's something that is not related with the pattern. The only thing related with the pattern is the update. That's it. Okay, observer with the update. Good. The subject. What can you tell me about this class subject? What do we have here? Yeah, answering the question in the chat, the listeners are implementation of this idea, this concept of the observer pattern. Yeah. Something that we need to review is, in fact, the listeners are an improvement of the observer pattern. A problem with the original observer pattern is this observer pattern, the original one, do not consider multi-threading or the question of security in multi-threading. Something that happened with the Java API, obviously, is they take care, at least after Java 9, of multi-threading and security with the threads. So somehow the listeners are going to become better than the original idea, but they are the same concept, patterns, observer and listeners. Now, the subject, what can you tell me about the subject? Let's see, it's a class. We have here a data structure. A data structure, did you notice it's a list? Do we understand that part, right? It's just a list, a data structure. A list of what? A list of observers? Why do I need a list of observers in the subject class? The solution is as follows. I have two guys. The first one is the subject. The second one is the observer. Let's be more specific. The subject, the observer. The observer is going to be a professor. The observer is going to be a ghost. The subject is going to be a student. The subject is going to be a pattern. The first thing that is going to happen in the relationship between them, assuming that this guy have here some kind of information that is important for the other, the first thing that is going to happen is this guy is going to tell this guy, I have a special interest in the information that you have. I want you to keep me posted about what happened with the information that you have. I am watching you. The second thing that is going to happen is that this guy, the subject, he needs to remember that this one is observing. What if I have another guy here, another professor, another ghost that is also interested in the information that the first one had? This guy needs to remember that they have a second observer, that there are two objects interested in the information that I have. Here, as a subject, I need to know, I need to remember who is observing me. That information? A linked list. A linked list of what? Of the observers that I have. A linked list of all the people that have told me that they want to know what happened with this information that I have. The class subject have this linked list to store all the people that have expressed interest in the information. Now, if you have a linked list or if you have a data structure to store information, which methods do you need for the data structure? Add and get. In particular, my friends in the pattern, they call it attach, detach. Methods to add, methods to remove. Add and remove what? Elements to the list. In this particular scenario, we do not need the get. There is obviously a method get, but it is not mandatory. In the class listener, you have the get. It's not something that you need for the functionality of the pattern, but well, adding, removing, getting. Do you remember the name of this method, the attach one? Talking about listeners, in particular, talking about the previous example with actual listeners. This sounds familiar. Do we have this data structure in the listeners? Moreover, do we have any method that looks like adding or removing something in the subject? When you create a listener, what is the first thing that you do with your listener? And do you remember what is the parameter that you pass? The parameter that you pass is the name of the object that have the action perform method. And the object that have the action perform method is an observer. What you are sending is you are asking for your observer to be added to the list of observers for one particular subject. Now, next step. If I am the subject and I have this information that is important for others, and I have this list of all the other objects that are interested in whatever happened with that information, the most important thing that I do is this. What I am doing there is a traversal from 0 to n, and for all of the people that I have here, for all my observers, I am calling a method. Notify observers. Notify observers. What I do to notify observers? I call a method in the observers. Which method? The method update. And how do we know that they are going to have a method update? Because they are observers. And if they are observers, they inherit from this particular interface. And it is mandatory that every single class that inherits from the interface have an update method. That is the reason, because here I am sure that I can call the update method in those guys. They have it. If they do not have it, they are not observers. And if they are not observers, they cannot be a parameter here. Okay, so you have the subject and you have the observer. The responsibility of the subject is two things: remember the observers, notify the observers. The responsibility of the observer, only one: have a method update. So this one can call it. Okay, so far good. This is my concrete subject that could be a Pac-Man. And as you notice, there is nothing there. Whatever is here is just the normal trivial source code for the class Pac-Man. There is nothing special. The only special thing is extending from the other class. What happened with this Pac-Man? Extend, subject, extending, inheritance. When Pac-Man extends subject, you are adding to the Pac-Man this linked list, this add, this remove, and this notify. All those methods and all that variables, you are inserting that here, but you keep separation of concerns. I am the Pac-Man, and the only thing that I have here is the variables and methods that I need as a Pac-Man or as a professor or whatever, and I am inheriting from this class subject all these things that I need to be a subject, all these things that I need to store my observers, to notify them that I did something special, whatever, two different classes. Okay, so what I do with this structure? What you do? Well, create an object. I can create a subject. Remember, my subject could be Pac-Man. I create a Pac-Man. And then I can create Ghost1 and Ghost2. And according with the implementation that I did before, somehow I need to connect Pac-Man dot add observer, attach, and pass as a parameter G1, or Pac-Man add observer and pass as a parameter G2. I have the Pac-Man, one object. I have the Ghost, two objects. And suddenly I connect them. I tell the Pac-Man, these two guys are going to be observing you. What that means? That in some point, this use one call, use one instruction, Pac-Man notify. And what is going to happen, if you follow the structure before, is with one call, the Pac-Man is going to tell all the ghosts that are observing, guys, I am here. X and Y coordinates, my new X and Y coordinates are these new coordinates. Two objects, connect them. One of them notify the others about any change in the information that I have. And you told me you need. What are you going to do with the information? I don't care, your problem. The only thing that I am going to do is to share with you that information. Listeners, you create your JBottom. And you add add action listener is this and is this. What happened with creating the listener? You can create a listener. However, something that usually you do for the listeners is you use this, which is the object in which you are. So your listener is the same object that you create to handle the class. This is not a good solution for the listeners. We're going to talk about it. But so far, listeners, observer, the same pattern. Okay, guys, I need to stop here. Sorry. So review this. We continue next lecture. Thank you, guys.